All right, it's a beautiful day. It's a Thursday. Tomorrow is going to be minus 610 degrees. So make sure if you're one of those people that uh, wears belly shirts that you cover up your belly so you don't get frostbite. And if you're wearing, you know, anything with bare skin, you got to make sure you cover it up tomorrow. You do not want to get frostbite. We have 9 questions here warming up with our section on rational numbers. They are fractions and decimals, and our operational sense with them is important as we go to try and tackle the next chapter on algebra, which uses fractional coefficients. So our first question is addition of two fractions. Of course, with addition, you always need to find a common denominator. We're going to use 20 here. Equivalent fractions will be negative 15, and notice how I'm putting the negative sign in my numerator. It's a good place to have it. Plus 4. When you're adding, keep your numerator, or add your numerators and keep your denominator. Your answer is negative 11 twentieths. Negative 11 twentieths, because negative 15 plus 4 is negative 11. In the second question, we're subtracting. The first multiple at 8 and 10 share, what is it? Anybody? 40. If you used 80, it ain't no big deal. You can use 80 if you want. But 40 is the first multiple they share. So it is good if you use it. The equivalent fraction would be negative 5 fortieths. Take away 4 fortieths. Subtract the numerators. Keep the denominator. Keep flip change. You end up with negative 9 twentieths as your solution for number 2. The third one, you're dealing with whole numbers, and the easiest thing to do before you start at all is simply think of your whole number as a fraction. Since you are working with fractions, the number 3 is technically a fraction over 1, and it helps people in terms of the algorithm to figure out what the answer is if they think of it as a fraction over 1. So we're going to multiply our numerators, we're going to multiply our denominators, and we're going to end up with negative 12 fifths, which is negative 2, and 2 fifths as a fraction, as a mixed fraction. Your third question, or fourth question, also deals with division and has fractions and whole numbers. So whole number we're going to think is over 1. Keep your negative sign in your numerator, change to multiplication to do division, and use the reciprocal. Again, I'm keeping that negative sign in the numerator. Multiply your numerators, you get a positive 2. Multiply your denominators, you get a positive 9. Your solution for the fourth question is 2/9. The fifth question deals with the multiplication of mixed fractions, always easiest to think of them as improper. So I'm going to change both of those to improper. Once I have it in improper form, I can multiply my numerators to get a positive 12, multiply my denominators to get a 6. 12 over 6 in lowest terms is simply the whole number, 2. Your sixth question is division of mixed fractions. Again, change them to improper. Since I am dividing, I remember that I'm not supposed to divide fractions, or you can, but the easiest way to do it is to multiply by the reciprocal. So I'm going to change it to multiplication by the reciprocal. Multiply the numerators, you get negative 40. Multiply the denominators, you get 18. How many 18s are there in 40? There are just 2 of them. That's 36 plus 4 18s left over. In lowest terms, that's going to be negative 2 and 2/9. Our last 3 questions are decimals, and actually our last question is algebra. So our next 2 questions are decimals, rational numbers, operations with rational numbers in decimal form. We have a negative 1.2 divided by negative 0.2. Now, if you think of it as money, you have $1.20 divided into piles of 20 cents. If you have $1.20 divided into piles of 20 cents, you can make 6 piles, which is your answer. Alternatively, 1.2 divided by 0.2 is the same thing as an equivalent fraction if I multiply both by 10. It's 12 divided by 2. If I get rid of the decimals and think of it as an equivalent division with no decimals in it, and my solution would also be 6 if I did it that way. That's another way you could have done it. Question 8, $1.75 or a negative $1.75, excuse me. By the way, this was a negative and a negative, which made a positive anyway, so it's still positive 6 when it's a division of 2 negatives. I know my answer is going to be negative because it's a negative multiplied by a positive. If I think of $1.75, if I multiply it by 2 in my head, I get $3.50. If I multiply that by 2 again, I get $7, which is your answer. Alternatively, just keep your numbers like this, line them up. 5 times 4 is 20, carry your 2. 7 times 4 is 28, plus 2 is 30. 4 times 1 is 4, plus 7, 2 decimal places. Your answer is still, no matter how you look at it, a negative 7. And our last question, 2 divided by what number is equal to 4? If you tried to solve it by inspection, your brain probably melted a little bit, right? It was pretty tricky to think about 2 divided into how many groups is 4. Hard to think of. But if I think of it as $2 divided into piles of 50 cents, how many piles can you make? 4. So you could reason it that way mentally. But the easiest way we're going to solve it is I'm going to multiply both sides by x to start. Okay? Now, if I multiply both sides by x, process-wise, we understand that those are opposite operations. Whatever number that x is, if I'm dividing by that number and multiplying by that number, they are opposite operations, leaving me with just 2. And on the other side, if I take 4 and multiply it by x, I get 4x. Now I have a 2-step algebraic equation, or a 1-step algebraic equation, excuse me, that I'm familiar with. Divide both sides by the coefficient, and x will equal 0.5.